Myself Deepak, me and our friends going to present about climate change resilient crop selection using decision trees. Our teammates are myself Deepak, Raju GH, Sandeep Shivanand Balla, Yuvraj V Bajantri. We are guided by Nayana ma'am, assistant professor, and we are going to submit this presentation to Sanjay sir, assistant professor and PBL coordinator. Contents. Today we are going to see following contents: problem statement, justification, backgrounds, research, identification of variable, key variables, methodology, step-by-step process, data collection, algorithm selection, evaluation matrix used, implementation. Introduction. Climate change is a major threat to global agriculture affecting crop yields, soil health, and food security. Unpredictable rainfall, temperature variations, and extreme weather events make traditional farming method less effectively. To combat these challenges, machine learning models, particularly decision trees, offer data-driven solutions to help farmers to overcome this main problem for changing climatic conditions. Today we are going to discuss the following problem statements. First problem statement: climate change is causing unpredictable weather leading to low crop yields. Second, farmers struggle to determine which crops will survive in changing climates. A lack of a data-driven decision making in agriculture results in food scarcity. The traditional crop selection is based on experience rather than real-time data. Decision trees can analyze climate factors and recommend the best crops. Next, further will continued by myself, my friend Sandeep.
Good morning, everyone. Myself, Sandeep Balla. Farmers choose the right crops, reducing financial losses. By using data-driven approaches, farmers can select the. Yeah, on the was. Hello. Good morning, everyone. Myself, Sandeep Balla. My topic is justification. Helps farmers choose the right crops, reducing financial losses. By using data-driven approaches, farmers can select the crops they are best suitable for the regional climate, soils, and market demands. And the next point is support suitable agriculture by considering climate adaptability. Suitable agriculture aims balance environment, health, and productivity. And climate adaptability ensures that the crops which are chosen withstand temperature changes and rainfall variations and other climate factors. And third point is assistant polymarkers and in planning for food security agriculture stages. Governments and agriculture organizations can use it in data machines learning to credit policies to improve food security, ensuring stable food products and distributions and etc. The fourth point is uses machine learning to improve productivity accuracy. ML algorithm analyzes vast amount of data for examples like weather, patterns, soil conditions, and past yieldings. Decision trees are simple, intuitive, and easy to implement. Decision trees by using ML algorithm helps in making clear and logical decisions. And the next slide. And the next is background research. In background research, first point is studies show that temperature, rainfall, and soil properties affect crops growth. Scientific research indicates that environmental factors such as temperature, preparation, and soil quality directly impact how well crops grows. And second point is traditional methods use statistic agriculture models while ML providing dynamic instance. Conventional agriculture models rely on fixed historical data and assumption machine learning. On other hand, can analyze real-time data, recognize patterns, and adapt prediction dynamically. Third point is decision trees are widely used to medicine, finance, and now agriculture. Decision trees from a form of ML have been successfully applied in various fields like healthcare and banking or decision making and predictions. And fourth point is research indicates that real-time climate data improves crop yield predictions. Studies suggest that constantly updates climate data such as temperature and rainfall changes. And fifth point is existing agriculture models struggles to adapt to rapid climate changes. Traditional farming models often fail to keep with entrepreneurial climate shifts. Next. And this slide is about identification of key variables. First is temperature determines the best resistance of crop. Different crops have varying levels of tolerance to heat. Temperature affects plants' metabolism, growth rate, and surveillance. Rainfall affects soil moisture levels and water availability. Rainfall is essential for maintaining soil moisture, which directly impacts plants' hydration and growth. Soil pH influence nutrition available and plant health. Soil pH determines how well plants can be absorb nutrients. Certain crops thrive in acidic soil will other require natural or alkyl conditions. Humidity impacts plant growth, disease resistance, and transpiration. Humidity levels affect plants' release moisture. High humidity can promote fungal diseases, while low humidity can cause excessive water loss. Crop yield data helps train the model with historical crop success rates. Historical crop yield data provides insights into that farming conditions have led to successful harvesting in the past. And next will be continued by teammate Raju GH.
Good morning everyone. Myself Raju Dias. We are discussing about the climate change resilient crop selections. Next move on to the methodology in climate change resilient crops using decision trees. Step 1, problem understanding and object definition. In this problem understanding the impact, identify the impact of climate change agricultural and define the goal. Selecting the best crop based on the climate factors like temperature, rainfall, soil, pH value, humidity. Next step, we go on to the data collection and pre-processing. In the data collection, we have gathered the climate data like temperature, rainfall, humidity, soil, pH value. Obtain the historical crop yield data from government databases, sensors, and farmer records. In pre-processing, handling the missing values, impute the missing climate data, normalizing the numerical values like scale, temperature, and rainfall, encoding the categorical values like convert the crop types into numerical form. And step 3, future selection and data splitting, identifying the most relevant features affecting the crop field. Split the data set into training 80% and testing the 20% test for the model evolution. The next step is the model selection and training using the decision tree. Why using decision trees? Because easily interruptible and examinable, and handles the multiple factors like temperatures, rainfall, soil pH value effectively. Work well when given the data sets. Train the decision trees using the Gini index or entropy for splitting decisions. Adjust the hypermeters like tree depth, minimum samples for the leaf for the optimization. The next step is the model evolution and performance matrix. In evaluate the model using like accuracy score, confusion matrix, and precision and recall. Measures the overall correctness of the predictions and show the in confusion matrix show the false and positive and negative false negatives. And precision and recall ensure the model mischiefly important crops. In validation process, cross the validation to prevent the overfittings like using the random forest or SVM. Using the deployment or recommendation system, deploy the trained model using the web or mobile based applications, and integrate the IoT sensors to provide the real time data updates, and generate the dynamic recommendation based on their changing the weather conditions. Like future enhancements, use deep learning models to improve accuracies and satellite based weather prediction for the better forecasting, and develop a chatbot assistance to provide the automated crop selection. And these are the steps to provide the crop resilient crop selections. Next, move on to the flowchart to understand the process of climate change resilient crop selection using the decision trees. Flowchart, you have go to the start and collect the data, gather the information on soil, pH value, temperature, humidity, and rainfall. And next move on to the pre-processing data and clean and normalizing data for analysis and train decisions for tree model using historical data to train the machine learning model. The next step is the predict the best crop based on the current conditions. The model predicts the most suitable crop. And next we move on to the recommendation to farmers, provides the enhance and suggestion for optimal growth. And these are the steps of the flow chart. We have next move on to the climate collections or data collection. By the definition of data collection is the process of gathering the relevant information of the training decision tree to predict the best crop based on the climate conditions. What are the key data parameters like soil pH value determines the soil acidity or alkalinity affecting the crop growth, and temperature different crops thrive in the different temperature ranges. Humidity affects the plant growth and decision susceptibility. In rainfall for the using for the irrigation and overall crop yield. Soil type and using the sandy loamy or clay soil input from crop selection. In the past crop yield, historical data helps in the predicting future trends. We are using the data sources like weather stations or IoT sensors, real-time climate monitoring. In agriculture research reports like past trends and expert studies. In the satellites and remote sensing data like large-scale monitoring of soil and climate. In further data sources using the farmer surveys and government databases like ground level insights. And next to move on to the next slide, we have go to the algorithm selections. Why using the algorithm selection for the decision trees? Algorithm selections involves the best machine learning model to analyze the collected data and provide accurate predictions. Why we use decision trees for the crop selection? For using the interruptible and visualization, decision trees are easy to explain the simple if else conditions and handles the non-linear data to manage the complex relationships between climate and variables. And efficient for the small to medium data sets works well even with the limited data. And future selection build, it automatically picks the most important variables like pH value, rainfall. How the decision trees work in crop selections like in the root node, start with the most important factors like a rainfall is greater than 500 mm. The decision branches splits the data based on conditions. If the pH value is less than 5.5, it recommended wait, else it is rice. Leaf nodes finally predict the best crop choice. The alternative ML algorithm, why they are not chosen? Because it requires the large data set or slower real-time decisions using the for the interruptible and visualization. It is easy to simple explain and can manage the complex.
Myself, Yuvraj Vijay. My, my topic is evolution matters used. Accuracy source measures how many current crop predictions the model makes. Preparation and roll calls checks false positives and false negatives in the classification. F1 source balances the preparation and roll calls for more reliable results. Confusion matrix helps to analyze many misclassification errors in the model. Course validation ensures the model is not over filtering the specific data. Next slide. Implementation and feasibility. The model can be displayed as a mobile app or a website for a easy farmers access. Provides real-time crop recommendations based on climate conditions. Farmers can enter temperature, rainfalls, and soil data to get crop lessons. The system is scalable and can be applicable for different regions. Implementing the IoT sensors for automated climate monitorings. Thank you.